Hi guys, we discuss physical pendulum in this session. Physical pendulum. Physical pendulum. Physical pendulum. Physical pendulum means real. Physical for real. We take any a body. We take any a body like this and hinge from this point. This may oscillate about this point, about perpendicular plane, or we may hinge a rod from the end, and rod may oscillate. We may take a ring, hinge from here, and ring will oscillate in this plane. So we take any a body, and make it as a pendulum is known as physical pendulum. Physical pendulum. Physical pendulum means any body that have size is hinged from a point in the body and make oscillation is known as physical pendulum. Let us suppose there is a body hinged from this point and center of mass is here and mg is acting in this direction. So about this point, initially there is no torque. Torque on the system is 0. Now displace this body by making some angle. So what will happen? This body goes like this. Hinge point is this. Now center of mass is here. And suppose this distance is x. So mg act downward. And if this angle is theta, this angle is also theta. So a torque will develop on the system. Mg sin theta and this distance is s. So torque acting on the body is mg sin theta into x. But theta is anti-clockwise and torque is clockwise, so a negative sign generates. And we know torque is I alpha. So what is alpha? Alpha is minus mg sin theta x over I. So alpha is minus mgx over I into theta, as sin theta is theta when theta is very small. So what is alpha? Alpha is mgx over I into minus theta. Comparing with a standard equation of SHM, we can say omega square is mgx over I. So what is omega? Omega is under root mgx over I. So what is time period? Time period is 2 pi over omega. So that comes out to be 2 pi under root I over mgx. So this is the time period for a physical pendulum. For a physical pendulum. For a physical pendulum. So what is I? I is about hinge point. I is moment of inertia about hinge point. And what is x? X is minimum separation between hinge point and center of mass. Minimum separation between hinge point and separation of mass. Application. Suppose there is a ring. There is a ring of mass m, radius r, and this point is hinged. So what will be the time period of this system? What will be the time period of this system? This is hinge point. Here is the center of mass. So center of mass and hinge point separated by a distance x equals to r. And hinge point, about this point moment of inertia is mr square. And using parallel axis theorem, moment of inertia about this point is 2mr square. So what is the required time period? 2 pi under root I over mgx. So that equals to 2 pi under root I is 2mr square mg into r. M gets cancelled, r gets cancelled. So time period is 2 pi under root 2r over z. So this is a required answer. In application 2, suppose there is a rod. Hinged at one of the end. Rod having length L0, mass M0, center of mass at a distance of x equals to L by 2, L0 by 2. So what will be the time period for this rod system? As we all know, moment of inertia about this hinge point. Here is the hinge point. So this about this axis, moment of inertia is ml0 square by 3. So using these given information, time period is 2 pi under root I over mgx. So that equals to 2 pi under root I is ml0 square by 3 by mg, and x is L0 by 2. So 2 pi under root m gets cancelled, L0 gets cancelled. So 2 by 3 L0 over z. This is our required time period. Now suppose rod is hinged at a point that is at a distance y from the center of mass, or x from the center of mass. So what will be the time period? From parallel axis theorem, here moment of inertia is ml square by 12. So what will be moment of inertia here? Using parallel axis theorem, moment of inertia is mx square, ml square by 12 plus mx square. So time period is 2 pi under root I is what? ml0 square by 12 plus mx square, I over mg into x. So time period is 2 pi under root m gets cancelled. So 2 pi under root 1 over z L0 square by x plus x. This is the required time for time period to be minimum, dt over dx must be equals to 0. So L naught square minus 1 by x square plus 1 equals to 0. It implies x equals to L naught. X equals to L naught. Putting x equals to L naught, we get to L naught. ml square by, here there is a 12, a coefficient of 12. So here 12, so L naught by under root 12. Under root 12. So this is the required position. So at x equals to L naught by 12, time period is minimum for a rod. What is under root 12? Under root 12 is 2 root 3. That is approximately 0.28 L naught. So time period is 2 pi under root. What is 2 pi under root 1 over z L naught square over 12x plus x. And what is x? And what comes out to be x? X is L naught square by 12. X is L naught by under root 12. So time period is what? Time period is 2 pi under root 1 over z. And L naught gets cancelled. So L naught over under root 12 multiplied to 2 pi under root 1 over z, L naught over 2 root 3 multiplied 2. So 2 gets cancelled. And time period minimum for rod comes out to be 2 pi under root L naught over root 3z. So this is the required minimum time period possible if we make rod as a physical pendulum. Rod as a physical pendulum.